Hello and welcome. This is Chapter 1, Section 2 of Analyzing Graphs of Functions. This will be our first part, or Part A, of this lesson. Our main objective today is determining if a graph has symmetry with respect to the x-axis, the y-axis, or the origin. So the types of symmetry. So the thing about symmetry is this is a geometric property that you've already done, and you did line reflection or line symmetry, which is reflection symmetry, and rotational symmetry, which is just rotating it around a fixed point. So in geometry, we reflected over lines such as the x and y axis, as well as if you did the vertical line of x equals 5 or y equals 2 or whatever, you were able to reflect it over that in geometry. You also talked about rotational symmetry, which is around, we always go about the origin, but you could do it with any fixed point, which can get a little bit more difficult as you move that fixed point. And we did a game or a activity, transformation golf, if you were in my class or a class that was similarly structured. So symmetry about the x-axis is just flipping around the y values, making the opposite of each other. So we're going to keep our x values the same. So notice the x, let me go ahead and highlight in the blue, the x value will remain the same, but what changes is the y value. It's y and then the opposite of y. So it'll flip vertically because that is what our y value is. The ranges will change, but the x's all stay the same. Now over the y-axis is the complete other way around. So the y values, if you notice, will stay the same, but the x values will be the opposite of each other. So it's flipping horizontally over the y-axis. And then symmetric about the origin is if we're swapping both x and y to the opposites. So let's go ahead and practice on this next slide. So for these next ones, it's just visually seeing what happens. And the rules I showed you in the other side will help if you need to, but you can just visually think about it. So reflection over the x-axis, y-axis, or the origin. First off, I just kind of like to highlight the axes. So this is my x-axis, and this is my y-axis, and the origin will be a twist, or a turn. So in this case, if I look at this green line, that's the y-axis. Is it symmetric over the y-axis, or sorry, the x-axis? The x-axis. We're looking at points here. If I match the y value, so this y is 2, well, the opposite of it would be negative 2, which there's nothing there. So this can't be symmetric over the x-axis. On the other hand, if I look over here, if I look at the vertical line, which is your y-axis, and if I look at any of these points, so let's look at this point here, the y value, that's 4 over to the left, would be down 3, and look at that pairs exactly with that one. And look at, if I go up here, it also pairs here, and it still pairs all the way over. So it's actually flipping over that y-axis. So this is y-axis symmetry. Now, origin symmetry is if I can, on this point, turn this piece of paper, and it would be the same thing. And you can just say the opposite values of each of them and see if it works. And this one, in fact, is not going to be origin symmetry because I cannot rotate this. So if I take and spin, let me unlock my rotation. Apparently I have it locked. So if I literally spin this, it's not the same. It's not the same no matter what it is, unless, well, that's almost the same. And I keep rotating it. It's not the same. As you can see, the peaks are not lined up right here. So you have this peak doesn't go up top where it was before. So if you keep rotating it, it does not have that symmetry around that origin. Now, similarly, we're going to look at this one. Again, I like to highlight the lines just to make them visual. So if I think about it, does this one reflect over this axis? Well, look how far apart, 2 over here and 2 that way. Nope, not for the y-axis. Now for this one, well, look here, that one's up for, nope, not under that one, not that one. And can I rotate this and it be exactly the same? So I'm going to rotate it and see, I want it to be going from the bottom right to the top left, if I think about it. So if I turn this, well, that one didn't work. But if I turn it upside down, it is in fact going from the bottom right to the up left corner. So that is a origin symmetry. It's just rotating about that origin as I turn it around and around. So this one is in fact origin symmetry because I can turn it 180 degrees and it's exactly the same. Now this next one, or this last one here, if you notice, it is actually, this point matches over there, like all of these match over this like magenta E purplish axis. Also for the green it all matches, so this has x-axis and y-axis, and also if you turn it, as you can see, it will be exactly the same upside down, which is that origin-based symmetry. So it has actually all three of these symmetries. So go ahead and check on your own these. I will pause it and have answers shortly. So hopefully you tried it. This one has all three. This one didn't have any of them, and this one just had origin symmetry. And this is a cubic function, x to the third, something of that nature, with not a vertical shift up or down. It might be actually x cubed exactly, but we'll talk more and more about x cubed, x squared, and other functions just like that. So what we're going to talk about, this is the thing I showed you in the beginning. These are kind of key things about those symmetries. X-axis symmetry is we're keeping the x's the same, the x-axis, the x stays the same, but the y is going to be opposite of each other. So we're going to take y and replace it with negative y. So if I wanted to figure out if it had that symmetry, I'm going to replace y with the opposite of y. And then if I wanted to figure out if it's y symmetry, y-axis symmetry, I'm going to take x and replace it with negative x, or the opposite of x. And then with origin symmetry, I'm going to replace x with negative x and y with negative y, which are the opposites of each other. So let's walk through some of those. Okay, in this example, we're testing an equation for symmetry about the axis and the origin. So we're going to figure out what they are, but we don't have a graph. And I would want you to do these algebraically and not just type it into a calculator. I will have you, or you will be able to type these in a calculator on a test or a quiz, but that is only to check. You'll still have to prove or show or justify this algebraically. So the first thing is we're going to just start by taking and replacing x with negative x. So that would be the y-axis symmetry. So if you go back, when you replace x with the opposite of x, that will be the y symmetry. Then if we place y with negative y, that'll be x-axis symmetry. And if we do both, that will be origin. So that is our first step, is just say we're going to replace x with negative x into this equation here. So how do I do that? Well, I'm going to just say y is equal to negative 7 times, we're going to, instead of have x, positive x there, we're going to put that negative x inside of here. And see, is that going to be identical? Is it the same as what we started with? If it is, then it will have that y-axis symmetry. So again, I'm going to say right up here, this is our y-axis symmetry. If this actually is true, then it will have y-axis symmetry. Well, if you simplify this, we get y is equal to, well, if I have 3 negatives here and a fourth, this turns to be positive. So it's positive 7x to the third, which positive 7x to the third and negative 7x to the third are not the same. So it does not, in fact, have y-axis symmetry. So we can't do that. So I'm just going to cross that one out. It's not that one, so I'm not checking the box. Now the next one is replace y with negative y. So replace y with the opposite of y. So now, doing that same thing, I'm going to move this up a little bit for some room's sake. Now we're going to do that. Let me go into a different color here. So now y is going to be the opposite of y. So we're saying the opposite of y is equal to negative 7x to the third. All we did was take this y, which is positive, and make it the opposite of it. So that's what we do for this. Let's write this as the x-axis symmetry. And then what we do is we simplify that. Well, there's a negative over here. I can divide it to the other side, which will give me, in fact, y is equal to 7x to the third. Now, that will mean that it is not the same as our original. This is still not the same as this, which that is not x-axis symmetry. But we do know that these, if these two are the same, if we replace x with negative x and y with negative y, that will tell us that this would be origin symmetry. Those have to be the same. These are going to be the same for that origin symmetry, or symmetry with respect to the origin. So symmetry. Okay, so we're going to do that same thing, that same process over here. So I'm going to move it over and kind of walk through that same thing over here. So like I said, we're going to start saying x to negative x, because that'll be your y-axis. Again, this is our y-axis symmetry. So if I replace x with negative x, what we get here is we have y is equal to negative 7 times x plus 2, which again, we're replacing that with negative x. This will simplify to y is equal to 7x plus 2. Try the next one. Let's do y to negative y. That's our next one. And again, that would be the x-axis symmetry. If I replace that, now I have negative y is equal to negative 7 times x plus 2. And again, if I look at that and I simplify that, I'm going to divide by negative 1 to both sides, so we still get y here. This turns into 7x, but this turns into negative 2. If I divide this by negative 1, I get y. Divide this by negative 1, it's positive, which is almost good, but if I divide this by negative 1, I get to negative 2. Notice how this and this are not the same, nor is this the same as our original. So none of these are the same, so that means there are no symmetries. So let's try 2 more examples together, then I would like you to try one on your own. So again, for that y-axis symmetry, we replace the x's. X is the opposite of x, and then for the x-axis symmetry, we do y to the negative y. So again, this is kind of like the opposite of what you think, but that's how we do it. And visually, if you look at the graph, that's what it is. So let's go ahead and replace that. So we have y is equal to 6 minus, and then we put in that negative x here. And we get that this is y is equal to 6 minus, well, if I square negative x, it's negative x times negative x gives me positive x, which is back to that. So notice how this is identical to that, which that tells us it is that y-axis symmetry. So again, this is for the y-axis, so we have y-axis symmetry. So if we check the last one, we do the same thing, except we're going to put this as negative y. And I have to make sure I click the correct writer. So negative y is equal to 6 minus x squared. We divide both sides by that negative 1, which gives us y is equal to negative 6 plus x squared. Notice that this red and this red are not the same, nor is this the same as that. Therefore, it is not origin, it is not x-axis, so it is only that y-axis. So one quick other one here before I have you try on your own. Again, replacing them, I'm going to put 12, and then I'm putting in that negative x plus 16y squared is equal to 3. If you notice that if I plug it into something that's squared or the fourth, it will just turn it back to positive. So in this case, we get 12x squared plus this 16y squared is equal to 3. Therefore, it is that y-axis symmetry. Now, if I do the same thing to the other one, we have 12y squared plus 16, and then we're plugging in that negative y here, and we're squaring it, it's equal to 3. And this ends up being the same thing. So 12x squared plus 16y squared is equal to 3. So these are equal, and it's all equal to this, so it's actually x-axis, origin, and y-axis, all 3. So please try to check this on your own. I will show the answers when we're done. You should have got that this is only y-axis symmetry, so if I replaced x with negative x, it would be the same. Just think about squaring x and negative x, they are the same. If I plug in negative y, it turns the rest opposite. And then this one is almost origin, it just has that plus 1, it'll be plus 1 and minus 1. It'll be just a very, very small difference.